Hello friends, I welcome you to your channel Engineering and Technology for You to learn the topic types of clouds in cloud computing. Basically, today we'll be discussing the deployment and service models in cloud computing. So the agenda for today is introduction, the NIST model, the cloud cube model, then deployment models, service models, and lastly the cloud reference model. So let us start with the introduction. Now most people separate cloud computing into two distinct sets of models, the deployment models and the service models. So the deployment model refers to the location and management of the cloud's infrastructure, whereas the service models consist of the particular types of service that you can access on the cloud computing platform. This is very useful demarcation that is now widely accepted. For better understanding of the deployment and services models of cloud computing, first let us understand the two models which gives us the working definition and the model that attempts to categorize a cloud network based on four-dimensional factors. So these models are the NIST model and the cloud cube model. So let us first discuss the NIST model. The United States government is a major consumer of computer services and therefore one of the major users of cloud computing network. The US National Institute of Standards and Technology, that is NIST, has a set of working definitions that separate cloud computing into service models and deployment models. Those models and their relationship to essential characteristics of cloud computing is shown in the figure. Here we have the deployment models: community, hybrid, private and public, and the service models: infrastructure as service, platform as service and software as service. And we have the different service attributes, that is broad network access, measured service, on-demand self-service and rapid elasticity. Rapid elasticity means it relates to the scalability. Then on-demand self-service means whatever you want to do with the resources from the cloud you can do. Then measured service, so this is here you will be charged as per your use. The service attributes will be pulling the resource. The NIST model originally did not require a cloud to use virtualization to pull resources, nor did it absolutely require the cloud support multi-tenancy in the earliest definition of cloud computing. Now first let us understand what is multi-tenancy. Multi-tenancy is nothing but the sharing of resources among two or more clients. The latest version of the NIST definitions does require that cloud computing networks use virtualization and support multi-tenancy, because more and more clients can use the resources. Then because cloud computing is moving towards a set of modular interacting component based on standards such as service oriented architecture, that is SOA, you might expect that future version of the NIST model may add those features as well. The NIST cloud model doesn't address a number of intermediary services such as transaction or service brokers, then provisioning, integration and interoperability services that form the basis for many cloud computing discussions. Then given the emerging roles of service buses, brokers and cloud APIs at various levels, undoubtedly these elements need to be added to capture the whole story. So in order to understand the complete cloud computing, we'll have to know the other roles of other services such as the brokers, the cloud application programming interfaces at various levels. Then only we'll be able to understand the total story of cloud computing. Then let us go to the cloud cube model. The open group maintains an association called the Jericho Forum, whose main focus is how to protect cloud network. The group has an interesting model that attempts to categorize a cloud network based on four-dimensional factors. In their paper, Cloud Cube Model, Selecting Cloud Formations for Secure Collaboration, the types of cloud networks you use dramatically changes the notion of where the boundary between the client's network and the cloud begins and ends. So that's why the four dimensions are very important. So the four dimensions of cloud cube model, they are shown in figure. So here you can see the Jericho Forum's cloud cube model. Here we have the internal and external. These are related to the physical location of the data. It determines your organization's boundaries. Then we have the proprietary and open. These are related to the ownership. So is a measure not only the technology ownership but of interportability, ease of data transfer. Now here interportability means when it is a proprietary, interportability will be less, whereas in case of open, the interportability. Then the degree of vendor's application lock-in. So that will be again, the lock-in will be more for the proprietary one, and for open it will not be so. Then the next we have the parameterized and deparameterized. So parameterized we call it as the PER, and deparameterized we call it as the DP. So is a measure whether the operation is inside or outside the security boundary or the network firewall. So this is concerned with the security boundary. And then we have the sourcing, that is in-source or outsource. So whether the service is provided by the customer or the service provider. So in case of in-source, it will be provided by the customer. Outsource means provided by the service provider. So taken together, the fourth dimensional corresponds to two different states in the 8 possible cloud forms. First is the parameterized, that is per, internal proprietary, that is IP, then internal open, that is IO, then external proprietary EP, and external open UO. And similarly for deparameterized DP, we have the internal proprietary IP, internal open IO, external proprietary EP, and external open UO. Thus, if you summarize this, we have per, then in this we have the IP, IO, EP, and UO. Similarly, for DP, we have the IP, IO, EP, and UO. These are the 8 total different categories. Then the sourcing dimension addresses the deliverer of the service. So what the cloud cube model is meant to show is the traditional notion of the network boundary being the network's firewall no longer applies to the cloud computing. This is the way how the cloud cube model makes it 4 dimensional. Then let us go to the deployment models. The deployment models define the purpose of the cloud and the nature of how the cloud is looked. Although cloud computing has emerged mainly from the appearance of public computing utilities, other deployment models with variation in physical location and distribution have been adopted. So the NIST definition for the 4 deployment models: public cloud, private cloud, hybrid cloud, and community. So let us go to the public cloud. The public cloud infrastructure is available for public use, alternatively for a large industry group, and is owned by an organization selling cloud service. For example, Amazon EC2 service, that is for the infrastructure as a service. Then we have the private cloud. The private cloud infrastructure is operated for the exclusive use of the organization. The cloud may be managed by the organization or a third party. Private clouds may be either on or off premises. Nowadays, you find that many of the colleges and schools in India are having their private clouds for the online class. So, and these clouds they may be provided by third party or by they are managed by the particular organization. Then we have the hybrid cloud. Hybrid cloud combines multiple clouds, that is private community, where those clouds retain their unique identities but are bound together as a unit. So it is a combination of the private cloud and the public cloud. A hybrid cloud may offer standardized or proprietary access to data and application as well as application portability. Then lastly, we have the community cloud. A community cloud is one where the cloud has been organized to serve a common function or purpose. So here the function or purpose should be common. It may be for one organization or for several organizations, but they share a common concern such as their missions, policies, security, regulatory, compliance needs, and so on. Community cloud may be managed by the constituent organizations or by the third party. So here you can see, here we are showing the private cloud, that is may be internal, and then public cloud that may be external, and then we have the combination of these two will have the hybrid cloud. And apart from this, we can have the off premises, that is external, and on premise, that is internal. So these are the different locations for the different cloud type. Then let us go to the service model. In the deployment model, different cloud types are an expression of manner in which the infrastructure is deployed. That means particularly the location. Now you can think of the cloud as a boundary between where the client's network management and responsibilities end and the cloud service providers begins. As cloud computing has developed, different vendors offer clouds that have different services associated with them. The portfolio of services offered adds another set of definition called the service. There are many different service models described in the literature, all of which take the following forms. That is XaaS, that is something as service. So X stands for something. So here cloud computing services, basically they are divided into three classes according to the abstraction level of the capability provided and the service model of the providers. So here we have the infrastructure as service, then platform as service, and software as service. So you can see this in the figure. So here you can see the service class, then main access and management tool, and the service content. So for software as service, we have the web browser as the access tool, and then the content will be the social networks, office suites, or customer resource management applications and video processing. Then for platform as service, we have the cloud development environment as the access tool, and the content will be programming languages such as the Java, Python, or the C#. Then we have different frameworks like .NET, then mashups, editors, structured data. This will be the content of the cloud platform. Then lastly, we have the infrastructure as service. So here the virtual infrastructure manager will be the management tool, and the content will be compute servers, that is the different servers for the computation, then data storage servers, then firewalls and load balance. Then let us go to the infrastructure as a service, offering virtualized resources such as computation, storage, and communication on demand is known as the infrastructure as a service. So computation means the processing power, then storage means nothing but the memory, and the communication is nothing but the network. Infrastructure as service provides virtual machines, virtual storage, virtual infrastructure, and other hardware assets as resources that clients can provision. So whatever the client needs as per his requirement, these virtual machines, storage, and other infrastructure will be provided to the client. The cloud infrastructure enables on-demand provisioning of servers running several choice of operating system and customized software. So the IaaS service provider manages all the infrastructure while the client is responsible for all the aspect of the deployment. This can include the operating system, applications, and user interaction with the system. Then infrastructure services are considered to be the bottom layer of the cloud computing system. So Amazon Web Services mainly offers IaaS, which is the case of its EC2 service, that is Amazon Elastic Compute Cloud, means offering virtual machines with a software stack that can be customized similar to how an ordinary physical server would be customized. That's why it is named as Amazon Elastic Compute Cloud EC2 service, because as per the need of the customer, the scalability can be there. Then users are given privileges to perform numerous activities to the server, such as starting and stopping it, customizing it by installing software packages, attaching virtual disk to it, and configuring access permissions and firewall rules. So these are the different activities which the client can do with the server. The server will be provided by the service provider, such as the Amazon. Then let us go to the next, that is the platform as a service. Now, in addition to infrastructure oriented cloud that provides raw computing and storage services, another approach is to offer a higher level of abstraction to make cloud easily programmable. So that is known as the platform as a service, PaaS. A cloud platform offers an environment on which the developers create and deploy applications and do not necessarily need to know how many processors or how much memory that application will be using. So that will be taken care by the service provider. So PaaS provides virtual machines, operating systems, application, services, development frameworks, transactions, and controls. So in addition to multiple programming models and specialized services, for example, data access, authentication, and payments are offered as a building block to the new application. So nowadays, whatever web applications are being developed, that will need the authentication and the payments. So for that, that will be provided by the service provider. The service provider manages the cloud infrastructure and the operating system and enabling software. The client is responsible for installing and managing the application that it is deploying. That's all. So that's why it is very easy to develop any system based on the cloud. For example, here Google App Engine is an example of platform as a service. It offers scalable environment for developing and hosting web applications which should be written in a specific programming languages such as the Python or Java, and use the service's own proprietary structured object data store. So building blocks include an in-memory object cache, that is memory cache, mail service, then instant messaging service, that is XMPP, then image manipulation service, and integration of the Google accounts authentication. So these are the services provided by Google's App Engine. Then let us go to the software as service, SaaS. Applications reside on the top of the cloud stack. Services provided by this layer can be accessed by end users through web portals. Therefore, consumers are increasingly shifting from locally installed computer programs to online software services that offer the same functionality. Traditional desktop applications such as word processing and spreadsheets, that is Excels, can now be accessed as a service in the web. So for that we have the Google Sheets and Google Docs. This model of delivering applications, known as software as service, elevates the burden of software maintenance for consumers and simplifies development and testing for providers. So SaaS is a complete operating environment with applications management and the user interface. For example, Salesforce.com, which relies on SaaS model, offers business productive applications such as the customer resource management that resides completely on their servers, allowing customers to customize and access applications on demand. So here the clients can customize their application as per their. Let us go to the cloud reference model. Now it is useful to think of cloud computing service model in terms of hardware software stack. So one such representation is called as the cloud reference model. Now this is shown in figure. Here you can see at the bottom of the stack is the hardware or infrastructure that comprises the network. So you can see all the hardware will be put at the bottom. So here we have the compute, network, storage, HVAC, power, space, VMM, images, then grid cluster, authentication, security. All these are part of the hardware and other things. Then as you move upward in the stack, each service model inherits the capabilities of the service model beneath it. So IaaS has the least levels of integrated functionality and lowest levels of integration, and the SaaS has the most. So that's why, as you can see here, IaaS will have the facilities, hardware, abstraction, core connectivity and APIs. Whereas the platform as service, it will also include the integration and middleware. Whereas the software as service, it will include all these, plus it will have the presentation, mobility, then presentation platform, APIs, then applications, data, metadata and content. And these are all linked with the particular service which is being provided. For example, IaaS, it is providing the hardware service. So it will have the compute, network and storage. These three types of services they are provided. The platform as service, it will provide the total environment, and the SaaS, it will provide the application, software as service. So then we have different scenarios here. Say for platform presentation, we have the data, video, voice, or maybe put in the embedded form or mobile or the desktop. Whereas we have different applications such as the embedded, or it may be native or web application. So accordingly the things will be provided from the stack, hardware and software. So this is how the reference model will work. So with this we come to the end of this video. If you like the video, press the like button, share with your friends and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon so that you get notifications for our future videos on this topic. Then thanks for watching. Have a nice day.